Hello, I am Indunil Sikurajapathi, and the title of my talk is The Effectiveness of Remediating Mathematical Common Student Errors in E-Assessments. I am a lecturer in mathematics and a PhD student in the Department of Engineering Design and Mathematics at the University of West of England, Bristol. I worked on this project as a part of my doctoral research with guidance from Karen Henderson and Reese Greenhill. Karen is an associate professor in technology and enhanced learning, and Reese is an associate professor in teaching and learning. We all are mathematicians at the Department of Engineering Design and Mathematics, UWE Bristol. This is the plan of my talk. I will briefly give some background knowledge related to the Common Student Error project at UWE. Then I will talk about the methodology I used to conduct the project, and then I will end the presentation by giving conclusion and discussion of the project. First, let's see what are CSEs. Here we consider mathematical misconceptions or mistakes due to carelessness as common student errors. Here are some examples shown. When you look at the first error, you can see that sometimes students think that 12 is greater than 6. Therefore, 1/12 is also greater than 1/6. If you take another example, here when asked to find the square of a negative number, here it is -3, students sometimes give the answer as -9. So you can see all these as errors can be considered as common student errors. We use the Davis E-assessment system as the CSE Enhanced Feedback Development Platform. Davis has been designed and developed by a team of mathematicians, statisticians, and software engineers at UWE Bristol. Davis is an algorithmic e-assessment system. It supports different question inputs such as numerical inputs, matrices and vectors, graphical inputs, and computer programs. It has a lossless data collection feature, and also it has number of student-friendly features such as shutdown recovery and pre-processing checks on student inputs. So when I started the project in 2017, Davis did not have a feature to capture CSEs in e-assessments, and that led us to form the following research questions. These are the research questions we formed. What CSE do first-year engineering mathematics students make? How to detect CS to improve Davis feedback to address these CSEs? The aim of the project is to introduce a method to detect CSEs and to provide tailored feedback in engineering mathematics e-assessment question on Davis. There are several benefits of answering this research question, such as Davis emulates a human marker. That means it provides instant enhanced feedback, highlighting possible CSEs made, and gives tailored guidance on how to improve student topic knowledge. And also, teachers can identify areas in which more help is needed in student learning. It will also improve student learning experience. And also it will beneficial to several disciplines and organizations which use the Davis. The first stage of the project was to collect CSCs made by first-year engineering mathematics students. Here are the assessments and practice tests delivered to first-year engineering mathematics students. They have regular weekly formative E-assessments, and also before the mid-module summative E-examinations, students are given access to mid-module revision test to practice their topic knowledge. These are delivered through Davis. At the end of the module, students have a final written examination. To collect CSCs, I found to collect CSCs, I first focus on the 2017-18 mid-module January e-examination, which was held under controlled conditions. The exam was run in 2 sessions, morning and afternoon, due to logistic issues. The parameters of the morning and afternoon session were fixed. During the exam, students are given booklet for their rough work. They use them to work out mathematical questions before submitting the final answer on Davis. After the exam, 298 students' rough work were collected. Then I used the Davis reporter to identify students who submitted most common wrong answers. Then I carefully examined respective student rough work to identify clue for any CSCs. I found 40 CSCs in 17 questions of the exam. I couldn't find any CSCs related to the question 1 and questions 4 of the examination. The bar chart on the right-hand side shows the number of times the principal CSC was triggered and the total number of incorrect answers for the question, for each question. Sorry. All of these 40 CSCs were found in 14 topics related to engineering mathematics, and they are listed on the next slide. The 14 CSC were found to be in the following mathematics topics. For more details on the outcome of the first stage of the CSC project can be found in this published journal. Let's see 2 of these CSCs now. This question asks to find the modulus of a given complex number. The correct answer to the question was 7.62. However, 70% of students who got the answer incorrect put the answer as 6.32. Their rough work showed that the misconception here behind this error is to take the square of a negative number, here square of -3, taken as -9. Hence, they got 6.32 as the answer. The next example shows here is related to differentiation. The correct answer to this question is 3/x. However, 51 students who got the answer incorrect put the answer as 3/5x. Their rough work showed that the misconception behind this error was to take the differential of ln fx to be 1/5x. Some students even wrote the reason for that in their rough work, and they said that since the differential of ln x is 1/x, hence the differential of ln fx is ln 5x is 1/5x. The literature suggests that these misconceptions happen when students overgeneralize a concept. After gathering all those CSAs, I started the second stage of the CSC project. First, I introduced additional performance indicators into each original question code so that it can capture CSC when they are triggered. Then I created detailed feedback to address those CSCs. On the right hand side, you can see a sample of an enhanced feedback I created. The CSC enhanced feedback addressed the first CSC example I showed you in the previous slide. As in the enhanced feedback, I highlighted what could have gone wrong in the report section. I used different colors and boxes to emphasize the important facts. I created clear, detailed step-by-step feedback. Then I provided additional notes where necessary. After that, we move into the next stage of the project. The stage 3 of the CSC project was the trial phase. We use this improved enhanced feedback question in the weekly test and revision test for 2019-20 cohort. We included 15 questions which captured 29 CSAs altogether in weekly tests and 9 questions which captured 21 CSCs in the revision test. 196 students receive enhanced feedback in weekly test and 129 students receive enhanced feedback in revision tests. 78 distinct students receive enhanced feedback for question in both weekly or revision tests. 247 distinct students receive enhanced feedback for question either in weekly or revision test. After the trial phase, our next step was to gather student perceptions on the CSC enhanced feedback they received. For that, we conducted an online questionnaire. The aim of the questionnaire was to gather student views on enhanced feedback they received. We wanted to know how and to what extent does the current enhanced feedback help students to change their conceptual understanding and facilitate their understanding of the subject. And also we want to find out what are their views on the user-friendly features on the enhanced feedback. There were four Likert scale questions and 3 open-ended questions on the questionnaire. 88% of the participant of the questionnaire agreed that the enhanced feedback improved their mathematical understanding. 73 agreed that the enhanced feedback makes them feel confident or comfortable with engineering mathematics. 95 agreed that the information on the enhanced feedback is relevant to the question asked. 87 said that they were satisfied with the overall structure of the enhanced feedback. You can find more about this questionnaire finding in this paper, which is under review at the moment. These are a sample of responses we received for open-ended question. What do you like about the enhanced feedback you received? Some said, very useful, well structured. Some said, got right to the reason the answer was wrong. Some told that it tells you what you have done wrong. Some said it is certainly useful, and so on. The sixth question on the questionnaire asked students what do they dislike about the enhanced feedback they received. Most of them said nothing. Some wanted to have more detailed feedback. For the future suggestions question, most of the participants echoed the same request we received to have detailed feedback. Some said it is good enough. The few participants suggested very valuable future decision to consider. Some suggested to prove enhanced feedback on all the questions, and one suggested to include videos of a maths teacher doing each question and talking through each step. After this, we came to the fifth stage of our project to evaluate the efficacy of addressing CSE. For the fifth stage of the project, we included 8 improved questions in the end of semester control condition e-examination for the 2019-20 cohort. The 8 questions tested for a total of 17 CSEs, but only 15 CSEs were triggered in the exam. We focused on those students who made CSE before the exam in either the weekly test or the revision test, and then data can be found in this table. The third column of the table shows the number of students who received the enhanced feedback before the exam, and the second column shows the number of students who answered the question correctly in the control condition exam. If you refer the bar charts on the right hand side, you can see that CSE we treated before the exam has high success rate. The lowest CSE rate being 46 and the highest being 100%. Then we compared the CSE occurrence before and after Davis has the CSE enhanced feedback feature. This table shows the number of times CSE were triggered and the total number of incorrect answers by student in 2017-18 cohort, that is before the enhanced feedback feature on Davis, and number of times CSE were triggered by the student who received CSE enhanced feedback before the control condition test, and the number of incorrect answers by students who received CSE enhanced feedback before the exam in 2019-20. This graph shows that the CSE percentage, that is the proportion of students who made CSE out of the total incorrect answers in 2017-18 in blue, and the proportion of the student who had received enhanced feedback before the exam but did not do did the same mistake in the exam in green. You can see that for 12 of the CSEs in the CSE percentage is lower for those students who receive enhanced feedback before the control condition exam. However, CSE percentage for three CSEs, CSE 1, CSE 9 and CSE 12 is still higher for those students who receive enhanced feedback before the exam. However, if you compare the number of CSE occurrence in 2017-18 with the number of CSE occurrence among the students who receive enhanced feedback in 2019-20, you can see that latter number is very low even for CSE 1, CSE 9 and CSE 12. We found that all these three CSCs, CSC1, CSC9 and CSC12 could be classed as mistakes. The CSC related to CSC1 was missing the negative sign when doing the completing the square. CSC9 was giving the exact value for e to the power ax when asked to calculate an approximated value for an e to the power ax using Maclaurin expansion. CSC12 was missing the negative sign when integrating sin x. Then we use remark facility on Davis to remark the January exam of 2018-2019 cohort to find more evidence to support finding. That is in orange color. 6 questions were used in the examination for all the 3 cohorts, 2017-18, 2018-19, 2019-20. We remarked 2018-19 exam with the new enhanced feedback code. These 6 questions treated for 12 CSCs and the data for all the 3 cohorts shown in this table. If you look at the blue and orange colored lines on the graph on the right hand side, which represent the CSC percentage from cohorts who did not have CSC feedback before their control condition exam, they are higher compared to 2019-20 for all CSCs except CSC1 and CSC9. Note that the question which captures CSC 11, 12 and 13 was not included in the 2018-19 e-examination paper. With these findings so far, we made the following conclusion for our CSC project at UWE Bristol. Now Davis has a new feature in detecting CSCs and emulate human marker. Now it can provide instant feedback, instant enhanced feedback highlighting possible CSCs made. It can give tailored guidance on how to improve their knowledge related to the topic. And also now we can easily address CSC in large cohort. And also long-term benefits of this feature outweigh the time to identify CSCs and write enhanced feedbacks. It can be utilized in other cohorts. Teachers can identify areas in which more help is needed in student learning. And also it's improved student learning experience, and also further development of Davis will be beneficial to several discipline and organization which use Davis for their assessment, and also similar method can be used to develop other e-assessment systems as well. So this comes to the end of my presentation. Thank you very much for listening.